Hello friends, welcome to my channel Programming in C in Python with RSK. Friends, I also have one more channel which deals with programming in C, and the name is Programming in C with RSK, where I have uploaded more than 50 videos on various topics of C. So request all of you, all my friends, to please subscribe to both of my channels. In this video, we are going to see basic variable types in Python. Well, the variable types are listed here: int, float, bool, complex, byte, and string. One by one, we will see how these variables are used in the program. There are basic types as well as there are derived types of variables in Python. Basic types are int, float, string, bool, complex, byte, etc. What are the ranges of these variables? Well, the int type range can be of any value. It is not restricted to a particular number. A int variable can be expressed in binary, octal, decimal, and hexadecimal number systems. So, a int variable can have a form of either a decimal number or a binary or a octal or a hexadecimal. How we mention whether a constant is a binary or a decimal or octal, that we will see. Binary constant starts with 0b or 0 capital B. A binary value expressed as 0b, this 1011 and all. If we assign that value to a variable having a identity A, and when we try to display that value on our screen using a print A statement, what we get is a decimal equivalent of the binary number that has been assigned to A. Octal starts with 0O or 0 capital O, and it is expressed as 00345, 0O1235, etc. If we assign this 00345 to a variable A and try to take out its value, when we run this kind of statements, what we get is the output of print A statement is 229 again, which is the decimal number equivalent of octal number 345. We can also assign hexadecimal numbers and bool type also to variables. Hexadecimal number starts with 0x or 0 capital X. It can be expressed as 0x45a, 0xff1, etc. Again, when we execute this code where we have assigned a hex value of 45a to variable A and take out the value of A on our console using print A, what we get is 1114, which is a decimal equivalent of hex 45A. The bool can have only two values, true or false. In Python, when we assign true or false to a variable as a bool value, then T and F must be in capitals. If we try to assign 0 or 1 to a variable, even though our intention is to assign a bool type 0 or bool 1, the compiler treats it as an int value. It will not take it as a bool value. That is why in Python, true and false are the values assigned to a variable when we want to assign that variable with bool type data. Again, when we assign true to A and false to B and display these values of A and B on the screen, we get true and false as the output. A float type has a range of 1.8 into 10 raised to 308. It's a huge range. We can also have a complex numbers assigned to a particular variable name. These complex numbers are expressed as 4 plus 6j or 11 plus 45j, etc., where j is called the imaginary part. Complex numbers are most widely used in mathematics and in many engineering branches. That is why complex numbers are very useful if they are available, or complex data type is available for a particular programming language. Then another data type is bytes. It represents binary data. Suppose we want to represent a number AAA123FF, which is a hex number. If we want to represent it in a binary data type format, then the expression that the statement we write, A is equal to B. B stands for bytes, byte data. Then there is a slash x double a slash xa1 slash x23 slash xff. This x here stands for hexa number, hexadecimal number. The number starts with notation B and the whole number, total number, is enclosed in single quotes. We can see here this is a single quote, and at the end of the number it's a single quote. When we do it on the with this statement or with this small executable program, what we get is when BB, to which we have assigned a number AAFF11EF, this is the hexadecimal number which we have assigned to a variable named as BB. When we take when this print BB statement, when it is executed, the value that is displayed on the console is this much. The same value what we have written exactly in the same format, the print statement displays the value of the byte type of variable on our screen. Now this is the third statement which we have written is print list bb in the brackets. List is a type of variable which we will be seeing in our future further slides. What we get as an output or as a result of this execution of this statement print list bb, we get a list comprising of 4 numbers. What are these numbers? These are the decimal equivalents of the hexadecimal bytes that a number in byte form is represented. Each /x and ff means it can be anything 00 or 01 or 1a or 2a. It represents 1 byte of hexadecimal value. So here there are 4 bytes of the hexadecimal value. Their equivalent decimal values are outputted by the print statement for print list bb. Then there is a string data type in Python. Actually here we are only going to see what are strings. There are a lot of information and there are a lot of functions and many other operations that can be done on strings in Python. All those details we will see in a separate video. It's a big video. A string in Python is a collection of Unicode characters. What we have seen in the earlier slides is there is no data type called char which can carry 1 character in Python. In Python, a single character is also a string. Unicode characters have individual int values associated with those. In for all the characters in English which we will be using here in a string is expressed by enclosing the characters forming it in either a double quote or in the single quotes or in the triple quotes. All these 3 types of quotes which we use for expressing a string in Python, they have their unique identities and unique functionalities. What we have done is a small program, demonstration program, where S is equal to I love Python, SS is equal to same, triple S is equal to same. But what is the difference? S is assigned with a value which has been enclosed in single quotes. SS has the value which has been enclosed in double quotes, and SSS is a string which is enclosed in triple quotes. You can see here the string is of 2 lines. In S and SS cases, the strings are of single line. So whenever we want to enclose a string of multiple lines, that string is enclosed in a triple quote. When we execute this program, this print S, print SS and print triple S, they output the actual string which we have been assigned to them. So triple S, you can see print SSS is equal to, in triple quotes, it is in multiple lines, in 2 lines here. In the same fashion, 2 lines appear as a result of print SSS statement. So if the variable, string variable, is assigned with multiple lines, then when we use a print statement, the same multiple line output will be displayed on the monitor. What is the difference in single quotes and double quotes in strings? There is not much of a difference. Only thing is how to use them, double quote and single quote strings, how to use double quotes and single quotes. The way we should use it is explained in this slide. We are assigning A with a love Python string where the whole string is enclosed in single quotes and Python is also expressed in single quotes. When we try to get out, print it, when we try to display the string on the monitor using print statement, print into brackets A, we get a syntax error, invalid syntax. The basic reason is a substring must not be enclosed in single quotes if the whole string is also enclosed in single quotes. How to correct it? I want that Python should always be in the form of substring. So A is equal to I love in double quotes Python and the whole string is in single quotes. Then I get the exact output from this 2-line program where love Python is displayed on the screen with Python in double quotes. Similarly, if we write a string and while assigning it to a variable A, if we use all double quotes for the whole string and part of string, we get the same syntax error, invalid syntax. So if we want Python to be in single quotes and the whole string is in double quotes, then we have to write love Python in a double quotes with Python in single quotes. Then we get whatever we want to display, love and Python in single quotes. How variables are declared? As we have already seen in our previous video, no need to place any kind of statement terminator such as a semicolon or dollar or anything like that. Just simply age is equal to 35 suffices and it is a valid variable declaration and definition statement. Another thing that we can see here is no data type declaration has been made. Age is equal to 35, age is equal to 211. Why no data type declaration? Because Python infers the data type by the context in which that particular data is being used in the program. Then A is equal to 20, which is a small a or lowercase a. Uppercase a and lowercase a are two different variables as Python is a case sensitive language. C is equal to 2345. There is an indent here. this will throw an error. It is very important in Python to follow the indentation rules. Whenever there is a indent, that indent must be followed by certain other kind of statements which we will see later on. Simply while declaring three variables, we cannot allow, or the Python doesn't allow, a indentation here. Now here b is equal to 45.34567. Looking at this number, Python will understand that b is a float type of variable and city is a string variable. When I tried to run a program with an indentation, what I got is indentation error. A is equal to 20, B is equal to 11, B has been written with an indent which is different than A. As soon as the program was run, I got an indentation error, unexpected indent, as a program output. Indent not allowed here. How to assign different, there are different ways a variable can be assigned with values in Python. One way is 3 variables or multiple variables or 5 or 10, whatever variables we want to assign with values. They are written on the left side of a equal to sign, and on the right side all these variable names are separated by comma. On the right side of the assignment statement or equal to statement, we write the values which we want to assign to these variables. They are also separated by comma. What happens is the values that have been appearing on the right hand side of the assignment symbol will be assigned to the variable names appearing on the left in the same sequence as that it has been mentioned. So what is the sequence here? Airline, flight num, fare, these three variables are there, and the values we want to assign is Air India a string, comma, AI1234 a string, and 3456.78 as a float constant. So Air India will be assigned to airline, flight num will be assigned with AI1234, and fare will be assigned with 3456.78 as the values. Another way is airline is equal to Air India, then there is a partition separator in the form of semicolon. What we are doing here is all the variables are being assigned in the same line in our program. That is possible, but in such case a separator between the statements which are appearing as a variable name and the value to be assigned there, all these statements are to be separated with a semicolon. This is called partition separator. There is a built-in function type which is available in Python, which gives us what kind of variable or what type of variable that particular variable is. Now it's a simple program. We have declared and assigned values to 4 or 5 variables A, B, C, D and E. What we see here, A is equal to 11, B is equal to 1.11, C is equal to true, D is equal to some string, E is equal to a complex number. So what Python will infer, A is assigned with a integer. So even if we are not mentioned anywhere as the type of variable A will be inferred as int and will be treated as int till it holds the value 11 or any other integer number. Similarly, B will be a float variable, C will be a bool variable, D will be a string variable, E will be a complex variable. So all these print type statements will display type of variables that particular variable name of the variable referring to. Here A, B, C, D, E are the names of the variables. Their type has been displayed. A is a int, B is a float, C is a bool, D is a string str and E is a complex class. These are all classes. Actually in Python all the variables belong to some kind of a class. When a int variable is available, then it belongs to a class called int. Similarly, there is a class called float to which all the float values or float variables will be belonging. Same is for bool, str and complex. One thing that we have to take care is, it is mandatory that the first letter in true or false, that is either T or F, has to be in capitals. If we write as a small t, it will throw an error or it will definitely will not get assigned to the variable which we want to assign the value of true or false. In Python, all the values assigned to variables are the objects derived from the respective classes. So when there is a value 11 which is an integer value, that value is actually an object of class int. Similarly 1.11 is an object of class float and so on. Then there is another function in Python called id, both small, I is a and D both are in lowercase. What they give us is the ID allotted to that particular object by the Python's compiler. In the same values we are assigned to A, B, C, D, E as we have seen in the earlier slide. When print ID into the bracket A statement is executed, we have got this value. This is the ID of object 11 and A is simply a reference to that object. Similarly, B is referring to an object 1.11, B is referring to object 1.11 and ID of that object is this 2, 3, 3, 4, etc. C has a object true in this case, and it is referred to, the object true is referred to by variable C, by identifier C, which we have assigned true to it, and its ID is this much. Similarly for D and E, these are all IDs. What is ID in Python? The Python built-in function ID returns a unique int value which identifies the object during its lifetime. So ID is a unique int value which is identifying that particular object till the program is running, or till the object is alive. So it is object's lifetime phenomena which keeps ID of that object intact and in the available form. What is this ID in C Python? It is generally the memory address of the object. So whenever any object is created, it is created in memory. In that memory's location's address, that address in C Python only, a object ID may be the memory address of the object, but that is not true for Python as a language. In Python, object's identity may not be the address of memory location. It is specifically true for all other implementations of Python except C Python. So when a variable is defined such as a is equal to 111, a is simply the reference to an object 111 created by, that object is created by compiler, and it has been allotted a reference a because our program wants that object to be referred to as a. How to use variables in program, that we will find in a better way in this slide. We have written a statement import math. Math is a module in the Python language. When we import a particular module, what we get is all the functionalities that have been built in that module are made available to our program. In this program, I am not going to use any kind of math functionality. It is just to demonstrate how we can import a module. Then we have declared a few variables a, b, sum, mult, num, and then we want to take out what kind of variable a and num is, what is the type of these two variables. When we execute this program, try to execute it, we get an error, name num is not defined. It simply means that when a particular name has to be declared for a variable in our program, it must accompany with its definition also. The reason is very obvious to understand. The Python compiler will deduce or infer the type of data that variable will be using, or type of data that variable is required to be used with context. Here there is no context for num as it has not been defined. So the compiler will not be able to understand the data type of num and hence the error. Then another simple program I mention here. A is equal to 10, B is equal to 30, name is ABCDEF, F num is 0, these 4 variables are declared. Then we want to know the type of the variable, that the type of these variables as being inferred by the compiler. So we give print type A, type fnum and type name. So what we get is A is an int variable, fnum is a int variable and name is a string variable. Then a small fnum is equal to 1.1 into a statement which gives us 11.0 as the output, and now the same variable fname has been defined as a float variable. Earlier, when it was holding or it was referring to 0, its type was int. As soon as it starts referring to 11.0, its class has been changed. Now it is a class float. So this is how context tells the compiler judges or knows the class of a variable through its context or through whatever is the value assigned to that variable. Here in this particular case fnum is int, and then the same variable fnum is now float. Variables, as we know, the values which has been assigned to variables are objects of respective class. All the values of the variables in Python are instances or objects of the class to which those variables belong. When a variable name is defined as A is equal to 100, then Python infers that 100 is an instance or object of type int to which identifier AAA is bonded. Now we run a small program where 4 variables has been declared and defined. A, B, B, C, C has been assigned with 100 and DDD with 111. This print statement gives us the value, displays the value on the screen. Then through this statement we are taking out the type of the variables, all these 4 variables which are all int, as is obvious from whatever value we have assigned to these variables. Then we take ID of all these 4 variables, AAA, BB, CCC, DDD. What we get is ID of AAA is this much, which ends with 4648. ID of BBB is also 4648 ending with 4648. ID of CCC also 4648 ending with 4648, and ID of DDD is ending with 5000. So what we can see here, ID of 100 or ID of AA, BBB and CCC is same because the value is same. 100 is the object to which we are just defining the name of those objects. Since all these 3 variables has been declared as or defined as 100, then the compiler will create only one object 100 and it will bound or it will bind the names AAA, BBB and CCC to this object 100. That is why we find all these three variables have the same ID. Now DDD is assigned with 111. 111 is different than 100, so 111 object is also created and that object is bounded to DDD name. Now if we change A to 111, what we expect? Since 111 is already available as an object which has been binded to a name DDD, what this statement does is it doesn't create another object 111, but the same object which has been created while assigning when we assign the value DDD to 111 to this variable DDD, that same object starts or A starts referring to the same object to which DDD is already referring to. So there is only one object which has two references, one is AAA, another is DDD. We can see here the ID of AA is now something ending with 5000, which is the ID of DDD, whereas ID of BBB and CCC has remained unchanged. They are same as whatever they are earlier. If we change A to 112, what happens? Another object, different object 112 is created, int object 112, and now that object starts referring to AAA. So name AAA, name BBB, CCC are all references. They refer to particular objects created by the compiler depending on the values allotted or assigned to these names. So this is how we define it pictorially. 100 is a object of class int. It is referred by all the three variable names AAA, BBB and CCC. So A refers to the ID 4648, BBB refers to the same ID, CCC refers to the same ID. Whereas another object is created when we assign DDD with value 111, and that object is 5000 ending with 5000. So DDD, and earlier it was referring to this, now it has started referring to 5000. AA, BBB, CCC are identifiers to which object's ID is bound, and these are all pointing to the same memory location in case of C Python, or they are referring or pointing to the same ID in case of other implementations of Python. Here again we are getting ourselves more clarification on objects and variables. A is equal to 12, then print ID A. So this is the ID ending with 6536. Now same A has been assigned with a value 13.45 in the same program. Now it gets another ID which ends with 6288. Then again ID A is assigned with 0. So a object 0 is created and its ID is different than earlier object of type int having a value 12 created by the compiler. Then A is assigned with true, so it is a fourth object which is true, that has been created and having a ID ending with 7504. So A is being assigned with different values which is causing creation of different objects which are being binded to the same variable name A. Let us make it clear pictorially. Earlier, print A is, when A is equal to 12, object 12 is created with this ID. When we change A and assign 13.45 to it, another object is created with this ID. When 0 is assigned to same A, third object is created which is having this ID, and when A is equal to true is assignment is made, a object called true is created with this ID. So what happens? Same A, the name is same, but it is being binded to different IDs progressively. So the first an object 12 is created and bonded to identifier A. Since this object 12 is referenced by A. When A is equal to 13.45, a new object is created which is rebonded to A. A is dereferenced from earlier object created and referred by A, which is 12, and it starts referring to a new object 13.45. Similarly for 0 and true. So A can be assigned with different values. Depending on those values, type of data type will be determined by the compiler, and it will create the objects, different objects, as the different values are being assigned to A. Then what happens to the earlier objects? Lastly, we have created A is equal to true, so true is the object. So what happens to 12, 13.45 and 0? As they are getting dereferenced. Here comes the Python's garbage collection mechanism. It will either destroy those objects 12, 13.45 and 0, or these items will be kept for further reference till the program's lifetime. Now what Python does, we cannot know, we cannot judge, but definitely these dereferenced objects are most of the time destroyed by garbage collection mechanism in the Python. If we want to have a simple analogy of object and its reference, we can consider train name Pune Vande Bharat, train number 26102. Both names identify the same train traveling from Pune to Nagpur. Object is same, which is a train from Pune to Nagpur. Train number and train name are two references of the same object. So if we delete train name, it will not delete the object, because that object is again being referred to by train number. A string variable defined as A is equal to I love Python in single quote, B is equal to I love Python in single quote, C is equal to I love Python in single quote, but the difference is P here is lowercase, whereas in these two P is a uppercase. So naturally there will be two objects created. One is I love Python with P as a uppercase letter, and another object will be I love Python with P as a lowercase letter. This I love Python uppercase P will be referenced by A and B, but will be having the same ID. Print type A, B and C, we get str obviously, ID A 2352, ID B 2352, ID C 1840. So this A and B are referring to a same object having a ID ending with 2352, whereas as soon as there is a change in case of P and lowercase Python, another object is created and that object is referenced by C. There are 33 keywords in the Python. These are all listed here. We can get the list programmatically through following program: import keyword, print keyword.kw list. Thanks for viewing, friends. Please like, subscribe and share this channel. Also please like, subscribe and share to my another channel, Programming in C with RSK. Its ID is given here. In this channel I have uploaded more than 50 videos dealing with various programs, various chapters or various features of language, C language.